You're asking me to find. In that
This
area,
is
there's a box. Yeah.
okay.
In that area, there's.
Okay, no problem. Write it here. So 6.549328. It goes on like this. Is this a rational number or an irrational number?
Is it irrational, sir?
Yes, superb. It is irrational number because after the decimal point, I know the first digit, second digit, third, fourth, fifth, sixth, I know. But even if you ask me to find out the seventh digit, I don't know because there is no particular pattern in which the number repeat. So this is irrational. Very good. So we'll try to solve a few questions and I'll give you guys few numbers and all you're supposed to do is tell me whether the given numbers are rational or irrational. That's all. Okay. First question 6543. Is this rational or irrational?
Rational.
Very good, superb. Square root of 9.
Rational.
Very good. It is rational because square root of 9 is 3. 3 is an integer. Integers are rational. What about the third one?
Irrational.
Very good, superb. What about fourth one?
Rational.
Very good. Because there is a pattern in which the number repeats. 354, 354, 354, 354, 35. Again, it would be 4. So things like that. Okay. And fifth one.
Irrational.
Very good. Superb. Always remember square root of non-perfect squares. Okay, so if it's not a perfect square and you're taking a square root of it, so it will be a irrational number for sure. So here is where I want to ask you guys an interesting question. Let's see how many of you guys can get this one right. So obviously this is a bit tricky question, but see. Pi. Is this a rational number or an irrational number?
Rational.
Why do you say it is rational?
So it has a value.
Even this has a value.
Yes, sir,
I'm
but
not asking
it
you
has
is this
value
real or
to-
imaginary.
So there's a rational value itself given to it.
What is
No,
it?
depends question where it's used. Now, sometimes we use the decimal value,
Okay.
and sometimes when we use the rational value, it's obviously rational.
What is the rational value that you use?
I think so. 22/7.
Very good. Yes. But listen, guys, the reason why I call this bit tricky is the fact that we have been lied all our lives. We have been lied to. The value of pi is not equal to 22/7, guys. Okay, the actual value of pi is actually 3.1415 and so on. But the actual value of 22/7 is 3.142857. Again, 142857. So 142857 will get repeated. So this is the actual value of 22/7. Because of the fact that both are closely related to 3.14, so instead of pi, we substitute 22/7. That is the only reason, but the value of pi is different, the value of 22/7 is different. So that is the reason the value of 22/7, this one is actually rational. Because needless to say, I'm able to write that in the format of p by q. But the value of pi is irrational. Okay, so if possible, I'm pretty sure all of you guys have scientific calculators with you guys. So after the session, make sure you guys find out the actual value of pi. Okay, and also find out the value of 22/7 and then compare it yourselves. They are not actually equal, they are more or less the same. They're close to 3.14. That is the reason why we substitute 22/7 in the place of pi. I guess clear so far?
Yes.
Okay. So moving on, divisibility test. So here is where we are going to discuss the divisibility rules. Obviously, divisibility rules are very important, guys. So make sure you guys remember all these formulas. For example, okay, guys. So let's say, for example, I'll take a common number for all. Let's take 1, 2, 3, 4, 5, 6. So this is a 6-digit number. My first question is this number divisible by 2? Very simple question. Is this number divisible by 2?
Yes, sir.
Okay, how will you check whether a number is divisible by 2 or not?
Last digit is even.
Very good. Or else in other words, I can say the last digit should be divisible by 2. Correct? Okay. Is this number divisible by 4? The same number. Is this divisible by 4? Come on, guys. Is this number divisible by 4?
Yes, sir.
Okay. How do we check whether a number is divisible by 4 or not? Yes, actually this number is divisible by 4. But can you please tell me how do we check that? Did you divide it normally?
Yes, sir. But if it's divisible by 2, then it should be divisible by 4.
Is that so? 14 is the number. Is it divisible by 2? Yes. Is it divisible by 4? No.
No.
But the other way around is definitely possible. If a number is divisible by 4, then the number is divisible by 2. You can say that, but not the other way around. Okay? Fine. So listen carefully, people. The reason why I straight away jumped from 2 to 4, leaving 3, is the fact that the divisibility rules of 2 and 4 are somewhat related. So what if we check for 2? You just check whether the last digit is divisible by 2. Same way, in order to check the divisibility rule for 4, all you're supposed to do is check the last two digits. What are the last two digits? 56. Is it divisible by 4? 56 by 4. Is it possible? Yes. 14 fours are 56. So if the last two numbers are divisible by 4, then the entire number is divisible by 4. Last two digits should be divisible by 4. Okay. Can you please tell me what should be the divisibility rule of 8? How do we check whether a number is divisible by 8 or not? See, it is similar to 2 and 4. For 2, you check the last digit and saw whether it was divisible by 2. For 4, you check the last two digits and saw whether it is divisible by 4. So for 8, you should check the last three digits. So it is 456. Is it divisible by 8? Come on, guys, tell me, is
Yes,
this
sir.
number divisible by 8? Guys, 456. Is it divisible by 8 or not?
Yes.
Yes.
Yes, sir. It is divisible, sir.
Sorry?
Yes, sir. It's divisible 57 times.
Yes. Yes. Super. So that is the reason why I jumped from 2, 4, and 8 because their divisibility rules are similar. Okay. And some of the other easier divisibility rules, for example, how would you check whether the number is divisible by 5 or not?
If it's a multiple of 5, the last digit or last few digits.
Okay, last digit should
Is it
be
5, 0?
0 or 5.
5 or 0. Super. Similarly, how will you check for 10?
Last digit must be 0.
Superb. Okay. Is there anyone who could tell me what is the divisibility rule for 3?
No, if you add all the numbers, it should be a divisible of 3.
Very good, superb. Sum of the digits should be divisible by 3. Very good, buddy. What is the sum of digits for this particular question?
$21. So it's divisible.
Very good. Because when we add all the numbers, I get 21. So 21, yes, it is divisible by 3. So the entire number should be divisible by 3. Okay. Can you guys tell me what is the divisibility rule of 9?
Same as 3, sir.
Sorry?
Same as 3. Sum of digits divisible by 9.
Very good, superb. So sum of the digits should be divisible by 9. That is the divisibility rule of 9. Should be divisible by 9. Now tell me if this number is divisible by 9 or not. If this number is divisible by 9 or not. Is that divisible by 9?
Yes, sir.
Are you sure? Because sum of the digits is 21. Is it divisible by 9? No, it is not divisible by 9. So the entire number is not divisible by 9. Clear, people? Okay. So moving on. What is the divisibility rule of 6? How will you check whether the given number is divisible by 6 or not? See, all these things we have already learnt in our schools. How will you check whether the given number is divisible by 6 or not?
Divisible
If
by
it is
2,
divisible by
2 and
2
3.
and 3,
Very good, super wins. 6 does not have a divisibility rule on its own. Okay, so if a number is divisible by 2 and 3, then the number is divisible by 6. Is this number divisible by 6? Is the given number divisible by 6?
Yes.
Yes, very good. Because obviously the given number is divisible by 2 and it is also divisible by 3 because we just checked the sum of the digits was 21. So the entire number is definitely divisible by 6. Similarly, can you guys tell me what is the divisibility rule of 12? What is the divisibility rule of 12?
if it is divisible by 3 and 4, then it is divisible.
Excellent, super. The number should be divisible by 3 and 4. So 12, just like 6, it does not have a divisibility rule on its own. So all you have to do is check if the number is divisible by 3 and 4. If the number is divisible by both 3 and 4, then the number is divisible by 12. But here's my question. Why did we choose the numbers 2 and 3 for 6, 3, 4 for 12. Why?
So 2 into 3 is 6 and 3 into 4 is 12.
Simple. But here's my other question. If you took 12, you can write it as 3 into 4, or else you could have written it as 6 into 2 also, right? But why did we not take this as the divisibility rule?
So 6 itself doesn't have a divisibility test.
Okay. So is that the reason? Good thinking, actually, good reasoning, but unfortunately it's wrong. That's not the reason. So here is where you should understand the concept of co-primes. Okay, and for a few of you, co-primes could be a completely new concept, so listen carefully. What is a co-prime number? The word co itself means I'm talking about a pair of numbers. Let's say, for example, let's take the same example 3, 4, 6, 2. What are the factors of 3, guys? What are the factors of 3? Guys, simple. What are the factors of 3? 1 and 3. What are the factors of 4?
1 and 2.
1, 2, and 4, obviously. Okay. What are the factors of 6?
1, 2, 3, and 6.
Superb. What are the factors of 2? 1 and 2. Now, you can call a set of numbers as co-primes if they don't have any common factor other than 1. But here, 1 is also common. 2 is also common. So they are not co-primes. Okay, so only co-prime numbers can be taken for the divisibility rule. Clear, people? And if you guys are wondering, sir, what is the point of me remembering these co-primes and all that? I'll just remember 12 divisibility rule is 3 and 4. Just leave it like that. See, if you remember this concept, you can find the divisibility rules of a lot of consonant numbers on your own. For example, you can find out the divisibility rule of 36. Okay. Tell me the number of ways in which I can write 36 as a product of two numbers. I can write it as 6 into 6, or else any other possibilities.
9 times 4.
Very good. Any other possibilities?
12 into 3.
Okay. Fine. Enough. So out of these, which is the co-prime? Which pair is a co-prime? Definitely not this. Out of these two, which one is a co-prime? What do you mean by co-prime? Those two pairs, they do not have any common factor other than 1. There should not be any other common factor other than 1, which is a co-prime.
Nine and 4.
Very good, super. So, in that case, you can say for sure that if a number is divisible by 9 and 4, then the number is divisible by 36. As simple as that. Clear, people? Okay, can you please tell me what is the divisibility rule of 24? What should be the divisibility rule of 24?
Eight into 3.
Very good. I can write this as 6 into 4, or else 12 into 2, or else 8 into 3, but out of this is the only co-prime. So this is my divisibility rule. So if a number is divisible by 8 and by 3, then the number is divisible by 24. That's all. Clear, people? Very good. So moving on. Let's say, what is the divisibility rule of 11? How will you check whether the given number is divisible by 11 or not? Come on, people, fast. How will you check whether the given number is divisible by 11 or not?
Sum of the alternative numbers must be subtracted.
Very good, excellent. For example, let's take a smaller number and then I'll explain it to you and then we'll move on to this number. For example, let's take 132. Sum of alternate digits. Okay, let me put it this way. Let's take 0. Okay, sum of alternate terms. If I add these two, I get 3. If I add these two, I get 3. So, odd places minus even places, sum should be equal to 0 or a multiple of 11. Multiple of 11. So here the difference is 3 minus 3, which is 0. So obviously this number is divisible by 11. Okay, similarly, let's take this one. 6, 4, 2. If I add them, I get 12. 5, 3, 8 plus 1, 9. What is the difference? It is 3. It is neither 0 nor a multiple of 11. So this number is not divisible by 11. Clear, everyone? Okay, guys. Now here is where this gets interesting. Okay, is there anyone who could tell me what is the divisibility rule of 7? Anyone? Divisibility rule of 7. Okay, so guys, listen here. Let me take a 3-digit number, let's say 343. And if I'm supposed to find out whether the number is divisible by 7 or not, here is what the process is. Take the last digit, multiply it with 2. So 3 2s are 6. What is the difference between 34 and 6? 28. Is this number divisible by 7? Yes. So this number is also divisible by 7. Last digit into 2 subtracted from the remaining digits. That's all. Similarly, tell me if this number is divisible by 7 or not.
It's not.
Very good. It's not divisible because the last digit into 2 gives you 2. The difference is 48. Unfortunately, 48 is not divisible by 7. So this is also not divisible by 7. Hope you guys are clear with everything that we have seen so far. Shall we move on to a few questions based on divisibility rules? Are you guys ready?
Yes, sir.
Okay. Try answering the first question. Now in this question, they are asked us to find out what should be the last digit. So seems like a digit is missing. So this is actually a 6-digit number. A digit is missing, but they have told us that the number is divisible by 9. So remember the divisibility rule of 9? What is the divisibility rule of 9? Sum of all digits should be divisible by 9. Add the remaining digits 7 and 3, 10, 4, 2, 6. So 10 and 6, 16 plus 1, 17. So 17 plus a single digit number should give you a number which is divisible by 9. What should be the value of x?
1.
Simple, super, very good. Now here's the second question. 3, 6, 4, 1, 2, and let's say the missing number, it's again a 6-digit number and it is divisible by 33. What is the divisibility rule of 33, guys? Can I write that as a product of two numbers such that they are co-primes?
It must be divisible by 11 and 3.
Yes, that's all. So the number should be divisible by 3 and the number should be divisible by 11. So they have already told me it is divisible by 33. So I know for sure that it is going to be divisible by 3 and it is also divisible by 11. Let's check one after the other. Let's go with the divisibility rule of 3. What is the divisibility rule of 3? Sum of all digits should be divisible by 3. Add all the remaining digits 10, 13, 14, 15, 16. So 16 plus a single digit number should give you a number which is divisible by 3. Okay, what could be the value of x? What could be the value of x? (16) plus what number gives you a number which is divisible by 3? Yes, there are a lot of possibilities here. Tell me one after the other.
2, sir.
2 is possible. Any other numbers possible?
5,
Very good. Any other possibilities?
8,
Very good. So these are the possibilities because 16 plus 2 is 18 divisible by 3. 16 plus 5 is 21 which is again divisible by 3. 16 plus 8 is 24 which is again divisible by 3. Clear, people? Very good. But we know that the number is also divisible by 11. So let's take that. 3, 6, 4, 1, 2 and the missing digit. So let's apply the divisibility rule of 11. So if that is the case, 3 plus 4 plus 2, what do you get? 9. Whereas on the other hand, 6 plus 1 plus x, I get 7 plus x. So what should be the value of x so that the difference between 9 and this sum should be 0 or a multiple of 11? Just substitute one after the other. The value of x, 2, 5 or 8, what is it? Yes, someone gave me the answer. Very good. Because only if I substitute 2 here, 7 plus 2 becomes 9. 9 and 9, the difference is 0. So 2 is the only possibility. So my answer is 2. Similarly, try to find out the answer for third question. One, 2, 4, 5 and dash 4, 2. Add the alternate terms. You get 11 here, whereas here you get 7 plus x. Let's take this as x. So what should be the value of x so that the difference is 0 or a multiple of 11?
Four.
Very good. Because if it is 4, it becomes 7 plus 4, 11. So 11, 11, difference is 0. Very good. What about the fourth question? They have told me the 12875 dash is a number which is divisible by 8. We know that the divisibility rule of 8 is the last 3 digits should be divisible by 8. So what are the last 3 digits? 750 what? So the last digit is missing. Which number in the range of 750 to 759 is divisible by 8? Come on guys, fast.
752 can be divided by 8.
Very good. So the last digit should be 2 because only 752 is divisible by 8. So it cannot be any other digit. Say for example, obviously the number is divisible by 8, so it cannot be an odd digit. So you can eliminate 1, 3, 5, 7, 9. So out of the remaining, 750 is not divisible because 720 is divisible 90 times. So apart from that, you have got 30 plus something. So it should be 32 because only 32 is divisible by 8. Clear? So the last digit should be 2. Very good, people. Fine then. So moving on, we are moving on to the next concept here. And this concept is what we call it as the power cycle. And what is power cycle? See, here is where you get questions of this sort. For example, 577 power 673. Okay, they will not ask you the entire number. They'll ask you to find out the last digit of this value. Clear? So that is the concept that we are going to look at right now. Okay. Okay, guys, listen carefully. Can you tell me what should be the last? What will be the last digit of 1 power 31? What will be the last digit?
1.
1, because 1 power any number is again 1 only here. Okay, same way. 11 power 21. What will be the last digit? Just the last digit.
One.
Very good. So here is where I want you guys to understand one thing. When the last digit of the base value, let's say for example 231, if the last digit is 1, you don't have to worry about what is there in the power value at all. The last digit is definitely going to be 1. Okay. My next question is 345 power 122. What will be the last digit?
One.
Is it 1?
Is it 0, sir?
No. Check 1
5.
after this. It will definitely be 5. See, what do you mean by 345 power 122? Which means 345 into 345 into 345. It goes on like this for 122 times. Just multiply these two. 5 5s are 25. The last digit is 5. Again, multiply this with this number. 5 5s are 25. The last digit is 5. So it goes on. When the last digit of the base value is 5, again you don't have to worry about what is there in the power value at all. The similar logic applies for 1, 5, 6. So no matter, see, if the base value ends in 6, you don't have to worry about what your power value is. The last digit is definitely going to be 6. 6 power 1, 6, 6 square 36, 6 cube 216. So 6 power any number, or else any number that ends in 6 power any number, it will end in 6. Same way, if a number ends in 0 power any number, it will definitely end in 0. So the power cycle of 1 is always 1, 5 is always 5, 6 is always 6, and 0 is always 0. So these are the easier ones. Okay. Here's the next question. Let's say my next question is okay, 29 power 36. What should be the last digit? When I'm talking about the last digit, you should only worry about the last digit of the base value. You don't have to worry about, even if it is 1, 2, 3, 2, 9. I don't care about the other numbers. You only have to care about the 9 part. Just see what happens in 9 powers. 9 power 1, 9. 9 square, 81, 1. 9 cube, 729, again 9. So 9 power 4, 9 power 5, 9 power 6. It goes on like this. Which means, listen carefully, if the power value is odd, then the last digit is 9. If the power value is even, then the last digit is 1. Clear? So what will be the last digit here?
1.
1, because the power value is 36, which is even. So the last digit is 1. Okay. So here's my next question. 34 power 123. Okay, 1, 2, 3, 4. So what did I tell you? When I'm talking about last digits, all you have to worry is only about the last digit. See what happens in general for 4. 4 power 1, 4. 4 square, 16. So last digit is 6. 4 cube, 64. See, again you got it. 4 cube, 4 power 4. 4 power 5, 4 power 6. Which means, if it is odd, it is 4. If it is even, it is 6. Now tell me, what is the answer for this one? What will be the last digit?
Six, sir.
Very good, because the power value is even. So definitely the last digit is going to be 6. Now this was a bit easier, not as easy as the previous one, like the numbers as 1, 5, 6 or 0, but finding out whether the power is odd or even is easy. Okay, but if you look at the other digits, 2, 3, 7 or 8, so here is where you're supposed to understand one thing very, very clearly. Let's say, for example, 172 power 343. This is the question. Again, you should look only at the last digit of the base value. Check what happens for 2's cycle. For example, 2 power 1, the last digit is 2. 2 square, 4. 2 cube, 8. 2 power 4, 16, so the last digit is 6. 2 power 5, 32. See, again I got 2. Okay, so 2 power 5, again I got 2. 2 power 6, 2 power 7, 2 power 8, again 2 power 9, 2 power 10, 2 power 11, 2 power 12. Clear, people? So this is how it goes on. But still, I did not find out the answer at all. I need 2 power 343. What will be the last digit? I cannot keep writing till I reach 343 so that I can find out which line it stands under. So what can I do is, so if you look at all the numbers in this particular line, they have a particular pattern. So 1, 5, 9, it goes on. Okay, the next one would be 13 and then 17, it goes on like that. So, and the unique factor about these lines is, take the power values divided by 4 and check for the remainder. What is the remainder that you get? What is the remainder that we get here? Guys, 5 by 4, what is the remainder?
1.
1. 9 by 4, what is the remainder?
1, sir.
1 again. So if the remainder is 1, then the last digit is 2. Whereas same way, here, what should be the remainder? Divide all these powers by 4. What is the remainder that you get? 2. Here, what is the remainder that you get?
3.
Here, what is the remainder that you get?
0.
Very good. It should be 0. Okay. So this entire concept lies based on the power value divided by 4 remainder. So what is the power value for this particular question? 343. So all you need to do is 343 by 4. And we know the divisibility rule of 4. So you just have to worry about the last 2 digits. 43 by 4. What is the remainder, guys? What is the remainder?
Three, sir.
3. If the remainder is 3, what should be the last digit?
8.
8. That's all. So when it comes to 2, the last digit can either be 2, 4, 8 or 6. But how do I check that? Divide the power value by 4. If the remainder is 1, if the remainder is 2, if the remainder is 3, and if the remainder is 0. That's all. Similarly, check if we have a pattern for 3. Come on guys, do it and tell me if we have a pattern just like 2 for 3. Three power 1, 3. 3 square, 9. 3 cube, 27, 7. 3 power 4, 81, 1. 3 power 5, 243, again 3. So it goes on just like our 2's case. So it goes on like this. Again the same concept. Power value divided by 4. If the remainder is 1, this is my last digit. If the remainder is 2, this is my last digit. If the remainder is 3, and if the remainder is 0. Now, let's say for example, I ask you guys a question from this. For example, my question is 123 power 122. What will be my last digit, guys? What will be my last digit here?
Three, sir.
How is it 3? Okay, 122. You're supposed to divide it by 4. I know the forced divisibility rule. It cares only about the last 2 digits. So 122. So we can remove the 1 part. Just look at the last 2 digits. 22. If I divide 22 by 4, what is the remainder?
2, sir.
If the remainder is 2, what is the last digit?
9.
9. That's all. Okay. So 3, 9, 7, 1. Similarly, check if we have a pattern for 7. Seven power 1, yes, it is 7. 7 square, 49, so it is 9. 7 cube, sir, I don't know the value of 7 cube. You don't have to worry. Take the last digits case and then multiply it with 7. 7 sevens are 49, 9. 9 into 7, 63, 3. 7 threes are 21, 1. Okay, 1 into 7, so 7 power 5 will again end in 7. This applies everywhere. See, listen here. 3 threes are 9. Okay. 9 threes are 27. This one. So 3 power 4, I don't know, sir. You don't have to worry about 3 power 4. Take this 7. Multiply it with 3. 7 threes are 21. You've got 1. Multiply it with 3. Again, you get 3. So this process repeats. So 7, 9, 3, 1. The process repeats. So again, it is going to be power value divided by 4. Remainder 1 case, remainder 2, remainder 3, and remainder 0. I'm going to ask you guys a question now. 567 power 561. What's my last digit here?
One, sir.
Last digit is 1 or the remainder is 1?
Oh, the remainder is 1 and the last digit is 7.
Very good, super buddy. So just take the last 2 digits, 61 divided by 4. So the remainder is going to be 1. If the remainder is 1, the last digit is 7. Super. Just one more minute, guys. We'll cover the 8th one and then we'll wind up for the session. Okay. Same way, if we check for 8 power 1, it is 8. 8 square, 64, 4. 8 cube, sir, I don't know 8 cube value, don't worry. Multiply this with 8. 8 fours are 32, 2. So 8 power 4, sir, I don't know the value of 8 power 4, don't worry. Multiply this with 8. 8 twos are 16, 6. 8 power 5, sir, I don't know the value of 8 power 5, don't worry. Into 8. 6 8s are 48. You again get 8. 8 power 5, 8 power 6, 8 power 7, 8 power 8. So it goes on. Again the same process. Power value divided by 4. If the remainder is 1, if the remainder is 2, if the remainder is 3, if the remainder is 0. Okay, so just one question. 678 power 678. What will be the last digit?
Remainder is 2, and it will be 8, and it will be 4.
Super, very good one. Because I'm supposed to worry only about the last two digits. So 78 divided by 4. I know 76 is divisible, so the remainder is going to be 2. If the remainder is 2, then the last digit is 4. So it's 8, 4, 2, 6. Okay, so I'm just going to give you guys one question as your homework. We'll continue from this particular question from tomorrow's session. So this is your question based on the power cycle. Find the rightmost non-zero integer of the expression 1430 power 343 plus 1470 power 367. Okay. And if you guys have any doubts, you guys can ask me right now, or else we can take a small break. Your next session starts by 2:30, I suppose. Do you guys have any doubts?
No, sir.
Okay, guys, fine then. So make sure you try to find out the answer for this question. We'll discuss this in our tomorrow's session. Okay. Fine, guys. Bye then.
Thank you, sir.